And now, among the properties of log, let's look at the following property. Now, generally, anytime we take log base a for whichever base it can be of a number a identically. So, as an observation here, then we can see that the number we're taking logarithm of is exactly or identically the same as the value a over here. That will equal 1. But now, before I generally conclude this, let's convince anyone learning from this lesson here through a few calculation problems. So the point of this logarithm calculation is that we're taking log base a of the number exactly equal a. We take log base a of a number exactly equals a. Okay. So now on the calculator of mine, let's look at log base 10. So this is base 10 right here, where the base is skipped. Log base 10 of 10. So the number that we're taking logarithm is exactly the same as the base. The answer equals 1. So now we can make note of that. This is just quick illustration right here. So log base 10 that we have tried previously with the calculator of 10. So the number that we're taking log and the base are exactly equal. The answer is 1. On the calculator, I can try natural log, or we can see this as log base e. So base here is base e, log base e of e. So to access, on this calculator, to access just the value of e, the value is right here, okay, right above the division key. So I will go second e. So this calculator here will understand this e as the constant value 2.718 and so on. And so this is log base e of e. And so notice again, my intention here is to calculate the logarithm of a number where it is exactly equal with the base of the logarithm. The answer equals 1. And so again, what we have seen just now, natural log or log base e of e equals 1. Okay. And now we can start stepping out of these commonly seen logarithms. Let's look at log base 5, where it's not immediately available as a key on our calculator, on any of the calculators. Log base 5 of, but here log base 5, the idea is the number we're taking log, the number that we're taking log out of is exactly identical with the base of the logarithm. You can mentally see what the answer is, but let me convince you through an actual calculation. So to achieve the answer from this, to get the answer for this on the calculator, we'll go as a choice, natural log. Anyone else can try the log base 10. I'm more comfortable with natural log, that's all. So natural log of 5, and I'm dividing that by natural log of 5. Okay. So this 5 here in the numerator is from the big number, and this 5 here in the denominator of my calculator is from the base. And the base and the number that we're taking logarithm is once again exactly the same. So now let's turn back to the calculator and look at the final answer. The answer equals 1. So that's a couple of explanations through the calculations on the calculator. We can now make a generalization. So anytime we're taking log base a of a number a, the answer will be as quickly as 1. And again, this is a property where it's easy enough to the point that no one needs to remember this. As you keep working through the problems, this property will stay in your memory. Let's now come up with a few examples here. And the intention of this example now is that we can just make some quick evaluation without a calculator. So I will not swing over to the calculator at all for these easy calculation problems. So let's evaluate log base 5 of 5. The answer is 1. And that we can call that part A. There are times we're asked log base pi of pi. The base here admittedly is not a nice looking number, but in the end the point is the number that we're taking logarithm and the base of the logarithm are exactly equal. The answer is 1, and we don't need any calculator for this. As another try, and I can start coming up with any base as ugly looking as possible. So log base 0.01235. Okay, but the number is exactly the same as the base, 0.01235. The answer is gladly just 1. And none of these calculations will require a calculator. And so now to give a general explanation, just to give a general explanation of why it's true with this property, then we can just see that. Allow me to give only one general explanation here. Think about log base A of A. In order to find this answer, the answer to the, so in my way of introducing logarithm, log base A of A is thought of as the following question. So this is a question. We want to find what power of base A to equal A. Okay, what power logarithm is what power of base A to equal A, and so base A to what power that can equal A. And so now at this point, anyone viewing this lesson should be completely clear that power 1 is the only answer. And so the answer to this question is now the answer to this. And that is the reason why, once again, we have that property arise, a reason right there.